This video is an SQL tutorial part 2. In this video we will discuss subqueries, joins and grouping. If you're new to this channel, I'm Karina. I have transformed my career from finance to data and now I help others to do the same one step at a time. For this tutorial, I'm using data that I found at kaggle.com, link in the description to this video. If you want to learn how to upload those files to your database, you need to watch part 1 of this video. As we already saw, databases can have multiple tables. Imagine you're working for a fashion retailer. There would be multiple tables in your database. One table will be with all available items in your stores, all the t-shirts, pants and other items you have, all their sizes, all their colors. Each of those items will have unique identifier, usually it's article or some SKU, some code that indicates it is a unique item with this size, with this color. Another table will be customer data, those who joined your loyalty program, so it will be names of your customers, their dates of birth, their personal details, emails, phone numbers. Other table will be employees table with names of all the employees who are working in your company, and of course you will have payment data. These tables have some relationship between them, and that's why we call those databases relational database. Since our previous video, I uploaded more files from that folder. So now we have the following tables. We have customers, order items, order payments, orders, products and sellers. For example, we look at our table orders, and here on the left hand side we can see a list of columns that exist in our table. We have order ID, customer ID, order status, etc. So we have order ID here, but if you open a table like order payments, it also has order ID. So there is some relationship between these two tables. And if you go to order items, we also have order ID. So you can see that all these three tables are related to each other. And also, if you look at our customer table, we have customer ID. And then if you look at orders, it also has customer ID. So these two tables are related. One customer might have several orders, which means that there is not one-to-one relationship, but one-to-many. So one customer might have several orders. Same if you have sellers and products, one seller might sell several products, which creates this one-to-many relationship. Usually when you look at tables, there is either one-to-one relationship, one-to-many, or zero relationship. If you look at our table customers, the customer ID will be called a primary key. The primary key is an identifier that is unique for every item in a table. Now let's look at table orders. Orders also has customer ID. In this case, this column is called a foreign key. A foreign key is a primary key taken from a different table. So in a table customers, it is a primary key, but in another table, it is a foreign key. So by referencing this primary key of a different table, it helps us to relate tables by performing a link between them. An understanding of keys and primary key, foreign key helps us when we start doing joins, when we start relate our tables. Now let's talk about subqueries. Subquery is a query within a query. In other words, it's also called a nested query. Let's have a look at one subquery. Imagine your call center got some notification about a specific order ID. The order was delivered, but there are some issues with it, and the person gave you order ID. And now you want to look back into details, understand who the customer is, and things like that. Let's create our first subquery. We have our orders table, and from our orders table, we want to pick a specific order. We know order ID, that's all we know. To get this information, we say select star from, then name of our table, which is e-commerce orders. Then we say where, so we can filter our data, where order ID equals a specific value. Let's pick any random value. Let's run this query. Now we have these details. Now we want to go back to our customers table. In the customer table, we have details like customer city, customer state. So I want to find out where this customer is from. So let's select this information. To do that, we say select star from, then name of our table, which is e-commerce.customers, where, and what we know, where the customer ID is the customer ID from our second query. We want to get details for the customer ID, this one. Remember, we ran this query and this is the result. Let's, instead of star, select only customer ID because this is the information we need. We will put brackets around it. This way we created this subquery. Subquery you can run on its own. So if you copy it into another window, you can execute, you can get a result. It can operate on its own. But let's go back. We want to get everything from e-commerce customers, where our customer ID equals this subquery. Let's run it. And now we have details for this specific customer ID. That's a customer ID. This is a unique customer ID. Now we know customer city and a customer state. When we started writing our query, we didn't know the customer ID. All we knew is an order ID. But by knowing that information, we were able to create another query within a query and find out what is the customer ID, what is the city, what is the state. For example, you have employees table where you know the name of an employee, and another table that has all the salary paid to employees. But in the second table, all you have employee ID and a salary paid. In the first table, you have employee name and employee ID. For example, you know only the name. So you can create the same subqueries. You can say select from the employees table where name and then input name, then you put brackets around it and you create the first query, which is select star from employees salaries where employee ID equals and then another subquery. So the order of operation is the subquery, which is located within the brackets, within the parentheses, will be run first. So at first SQL executes this code and then it executes the code around it. SQL always starts with the inner subquery and then followed by outer subqueries. The best practice is actually to use indentation, so make spaces before your subqueries. This way it's easier to pick which is an inner query, which is in outer query. Another best practice is to use capital letters when you're writing any keyword. So it should be like this, same for where, same for in, out. If the value inside of your inner query not found, if there is some mistake, the whole script will return nothing, because if your inner query returns nothing, it prompting the outer query to also return nothing, and you will see an error or returned 0 rows. And when you're debugging, when you're trying to understand where the error is, I usually copy inner query and run it in a separate window, see if there are any mistakes, and move this way to understand where exactly the problem happens, why suddenly I get 0 rows. Another keyword we will look at called in. This keyword is used to check whether the desired value is in a given list or set of values. Let's open a new window and create a new query. So from table orders, I want to see what possible order statuses there are. To do that, we say select, and what we want to select order status. If you open the table and a column's name and then double click on the name of the column like this, you can see it copied the name of the column into our window. So it's easier this way instead of typing the whole names from scratch. So we want to select order status from our e-commerce orders. I want to see what possible options of orders there are. So we got delivered, invoiced. Let's go back here and we will create another subquery. In a subquery, what we're doing, we're selecting all customer IDs from our table orders where order status delivered. And then we want to find out details about these customers. Again, we are creating a subquery. So select star from e-commerce customers. In the previous subquery, we knew exactly that it will be one specific customer. But in this case, we know that our inner query will return multiple values. It will return multiple customer IDs. To check that, we can copy this subquery, go again to this new window, let's run it. You can see that it returned us 96,000 rows. And if you just run it as it is with equal sign here, it will throw an error. Since we have multiple values, we can't use equal sign here. So let's run it with equal sign. You can see at the bottom it shows that we have an error, subquery returns more than one row, and equal sign works only with one row. But in this case, we can use our new keyword in. So let's replace equal with in, and run this one. And now we've got our result. So what happened? SQL at first ran this inner query. So it got all the customer IDs where order status equals delivered. And then it ran outer query. From the table customers, we got all those customers with the order status delivered and got details for them, like customer city, customer state. And you can see we have exactly the same number of rows returned, so 96,478, exactly the same value as we got here when we ran this subquery. Now you know how to create nested queries, and it's time to learn joins. If you use Excel, you probably came across lookups. For example, VLOOKUP is the same as left join, which we will discuss in a minute. So joins is a keyword that allows us to combine two or more tables together. So there are several types of joins, and similar to lookups in Excel, there should be something similar, some similar key that we can join those tables on. So if there are nothing similar between those tables, we can't perform joins. We have two tables, one is salaries and one is order items. Both of those tables have the same key, which is seller ID. If you run query select star from e-commerce order items, it will return us 112,650 rows. And if we want to check how many unique seller IDs we have, we need to use count distinct, which we learned in the previous video. Let's run this query. It says that we have 3095 unique seller IDs in our order items table. In a separate window, let's select everything from the table sellers. Let's run it. It returned 289 rows. In a sellers table, we have seller ID, zip code, seller city, and the seller state. While in our order items, we have order IDs, product ID, and the seller ID that sold those items. Similar to lookups in Excel, in SQL we can use joins to combine information from several tables. For example, I want all the data from order items, but I also want details about seller city and a seller state. So I want to join this data. First join we will look at called inner join. So we say select star from, we keep our table, and then we say join. Then we need to say the name of the second table. In our case, it is e-commerce sellers. That will be table number 2. Then we need to use on keyword, and on keyword is used to specify which values match between the tables being joined. It's impossible to join tables without matching values, so we always need to have values that match. So we say on, and then the value that matches in both cases is seller ID. So we need to say seller ID equals seller ID. But you can see this is very confusing. Now it's hard to understand what I mean because I said seller ID equals seller ID. What seller ID? To make it more obvious for SQL, we need to use alias. And usually you can give some descriptive name. You can say item or seller, or you can just use A and B. For now, I will be using A and B for simplicity. We will call our e-commerce order items table A, our e-commerce sellers table B, so you just need to say A and B after the space. Here on seller ID equals seller ID, we will say A dot, and we will add B dot to specify that seller ID from this table and a seller ID from table B from this table. And what we want, for example, we want a seller ID from table A, we want product ID from table A. Also from table A, we want order ID. From table B, we want a seller state. Let's execute this query. This is the result. But you remember that initially, if we run select star from order items table, we had 112,000 rows. So what happened to the rows? This is example of inner join. And the way inner joins works, if there are any IDs in one table not present in another table, those rows will not be present in the join table. After we made join, there must be some seller IDs that exist in one table, for example table A, but doesn't exist in the table B. And because of that, SQL returns only rows that match. So there are no missing values, no null values when we check this table. So if we do sorting by each of these columns, you can see there are no null values, no missing values, so all the data was joined. But what if you want to say, I want all the seller IDs from table A and their state if it is exists. If there is state, then okay. If there is none, don't return anything. Similar to VLOOKUP in Excel. So I want everything from this left table and some details from right table if they are available. In this case, we're using left join. Left join exactly like VLOOKUP in Excel. Here, instead of join, we're saying left join, two words. And the way it works, it will return everything from table A, from the very first table, and all the information that is available from table B. So remember that with this query, we return 10,228 rows with our inner join. Let's check how many rows we will return when we run our left join. We returned again 1,650 rows because we got all the information from our table A, which is the left table, and only the information that is available from table B. Now you can see that in seller state, in the column that comes from table B, there are some missing values. If we sort, we can see there are missing values. Another type of join is a right join, and it is opposite of left join. So with left join, our primary table is the first table. Right join, our primary table is the second table. So what I mean with left join, we are saying that we're joining on A seller ID equals B seller ID. If you use right join, we will get all the information from table B and the information that is available from table A. So let's change left to right. Let's rerun this query. We returned 10,228 rows because we got all the data available in table B and respective data from table A. Right join exists, but most of the time people use left join because it is easier to use. You need to know that there are the cases where sometimes it is a little bit more convenient for you to use right join, but in most of the cases you will use left join. There is another type of joins which is full outer join or full join, and it will return all the records when there is a match in the left or right table. It might return very big data set. However, I can't show you how it works because full outer join or full join doesn't work in MySQL. Other way of combining your data sets is union. Union is similar to VStack in Excel, where you're stacking your dataset one by one. With union, you need to say what columns you're selecting from a table. For example, I'm selecting seller ID from e-commerce order items, and I'm also selecting seller ID from table e-commerce sellers. And then I union both of those datasets. So let's select all seller ID from e-commerce order items and see how many rows it returns. It returns us 112,650 seller IDs. And if we rerun e-commerce sellers, let's see how many items are there. It returns 289 rows. When we union our data, it returns 3,095 rows. So you can see that this number is smaller than seller IDs in order items, but greater than number of rows in sellers. You could have guessed that union doesn't allow for any duplicate values, so it removes duplicates and leaves us with 3,000 unique values. But there are cases when you want all the data including duplicates. In this case, we need to use union all. The syntax will be exactly the same, and you can see this time it returned us 112,939 rows. It returned all the rows from order items and all the rows from sellers. I will show you another use of union and union all. For example, from order items, we want seller ID, product ID. When you use union and union all, quantity of columns you select from each of the tables must be equal. So if you select 3 columns from order items, you must select 3 columns from sellers. But what if you want to stack data, but you know for sure that one column doesn't exist in one table, but exists in another? For example, if you want to select seller ID and product ID from order items and stack it with seller ID and seller city from table sellers, but we know that product ID ID doesn't exist in sellers, while seller city doesn't exist in order items. In that case, you can create a placeholder, so it just creates a column which is empty, but when you stack, it will all make sense. So let's run this query. So we have seller ID, product ID, seller city, or 3 columns. But for example, here, this is information from our table sellers. We have seller ID and seller state, but we have no product ID because it doesn't exist. Instead, we have this product ID as a placeholder. And similarly for seller city, so here this is the information from our table order items where we have seller ID and product ID, but we don't have seller city. Instead we have this placeholder. And the last keyword we will talk about today is group by. Remember at the beginning of this video we were checking various order statuses from table e-commerce orders, and we saw of course there is delivered, paid, etc. So if we again select order status from table orders, it returned us 99,000 rows. But what if I want to know what are unique order statuses are there? So of course, to count unique order statuses, we can use count distinct. But what if I want to display them? What if I want to see? In that case, we need to group our data. And again, in Excel, if you've done pivot or if you use group by, pivot by functions in Excel, you know what will happen when we group our data. In SQL, we use group by keyword. So if we want to group our data by order status, we say group by, and we need to say group by order status. Let's run this query, and now it returned only 8 rows, displaying us only unique order statuses. So now we can see there is delivered, invoice, shipped, unavailable, etc. Group by is very important because it allows us to combine, create those groups and show only unique values. Otherwise, you return in all the rows available in the database. Also, once you start using aggregate functions, SQL will argue and say you must group data. For example, from our order payments table, we want to see all the order IDs, their payment value and payment type. Let's run this query. It returned 103,000 rows, so it displays us every order ID, payment value and payment type. What if I want to see all the payment types and their payment value? Imagine like pivot table in Excel. So I want to see all the payment type and total payment value for that payment type. So let's remove order ID, not use any group. Let's just run this way. It again returned us 103,886 rows, but I want this data group. Also, you can notice that based on the order of the values you indicate and select, this is the same order that you will get the data displayed returned to you. At the moment, my payment value is the first column, my payment type second column. So if you want to swap them around, you need to change it within your select statement. I want to get total payment value by payment type. I want a sum of values for payment type. Let's use a sum around our payment value, and let's run this query as it is. It gave us an error because we are aggregating our data. When you want to aggregate your data, you must use group by. Actually, SQL is hinting you about it. So that's why we need to add group by, and we are grouping by payment type. And now it returned us sort of pivot table where we get payment type and total of our payment values for each of those payment types. Remember that to rename our column, we need to add keyword s and then the name of the column, for example, total. Also, the best practice, as I said, to use capital letters for all the functions, all the keywords, but I'm guilty of sometimes swapping to lowercase. And remember, if you want to round, we need to say round to 2 decimal places. That's the final result. And the last probably keyword for today is having. If you want to filter your group data, aggregated data, you can't use a where statement. Instead, you need to use having. So we grouped our data, and for example, we want to display only those payment types where total is more than 300,000. So we say having and then total more than 300,000. And you can see this way we filtered our grouped data set. So instead of seeing the whole results, we will display only the results where total payment value is more than 300,000. Keyword where can only be used to specify conditions for individual rows, while having keyword is used to specify condition for the groups. And let's add order by, the keyword we learned last time. So if we want to now order or sort our data, we can say order by, and we want to, for example, order it by total column in descending order from largest to smallest. Let's run it, and now that's the final result. So this is the order of keywords. So select, from, then group by, having, order. That's the order of the keyword. So you can't say order by before group by, you can't use having before group by. That has to be the order. Select, from, group by, having, order by. This thing that I haven't shown you before. So now you have your results displayed to you, and you want to export this data and do further analysis in Excel, for example, building some graphs or dashboards. You can export data in MySQL. This is the little icon for that. You say export, you indicate the name where you want to export, and it exports in CSV format. Same can be done in SQL Server Management Studio. You can always export the results of your queries. That's enough for today. I hope you enjoyed those SQL tutorials. Please let me know if you want more, if I need to discuss some parts in more details, and I hope to see you next time.